G'day, I'm Michael Helmreich. This little video is about the problem with corners. The problem with corners is corners are a problem. I get asked by eBay customers and general customers how to solve corner problems, and so I thought I'd better prepare this little video to help explain things. I think I'll begin with a sketch. Forgive the perspective here, but I'll do my best to make it as clear as I can. Basically, when you have a corner, let's visualise this as perhaps these are walls, and perhaps, I don't know, the depth of a typical kitchen cabinet is 600mm both ways. And how clear that's showing up. Here. Okay, so there you have a corner. Now, what we always have a problem with is access to a corner. Now, the basic geometry of access comes down to how well you can fit a human body to that space to get access to it. Now, I like to allow in the vicinity of 600mm across any corner obstruction. I'm just looking for a pencil. Let's grab one. There we go. Tools of the trade. If the space is wide enough, that's 600, you want the diagonal about 600. This is somewhere near proportional. I don't know how well that's showing up. Clear that up a bit. Maybe I'll do it more heavily. So let's say we made the cabinet that size. Now, 600mm across the diagonal is not 600mm across the diagonal. 600mm is the resultant space of any components that might be involved with making that cabinet. If you have, say, a pair of doors that are swinging away, you have a hinge in this area and perhaps a hinge in the other area, all using space in that opening. So the 600mm is in fact applied to that kind of space. So you can see everything we do makes that access point smaller and smaller. So it works a bit better there. Okay, with the geometry of any corner, there's a few things to keep in mind. I've done a rough sketch here to speed things up from what I prepared earlier. The important geometry you have to deal with a corner is how you get access to a space. Now, I proposed a bench top, say 600mm here and 600mm the other side. You can see that very well. Okay, there's 600mm both ways. If you imagine your body, as in your shoulders, as a critical thing, needing clearance to get into that corner, we have hinges, structural elements of the cabinet, the thickness of the doors, whatever. If that was a corner pantry, you may have some shelves inside, maybe curved around like so. However you've designed the internals to be, that's irrelevant at this point. But what is relevant always is getting your body in and out of that space. Now, if it was simply an underbench space, where you've only got the doors going to a right angle, you have the same difficulty. You may have the full depth shelves both ways, but reaching the back corner still depends on you being able to get your shoulders in this area here so you can reach in to that corner. If this area is smaller than your shoulder space, I'll just draw in an example. Let's say that was your space now. Your body is out here, your head is there. You cannot reach the back corner, so basically the corner is lost. In that situation, you might be just as well off flanking the corner. So you can see there's some real issues with the basic geometry of a corner unit. Now, there have been quite a few solutions invented over the period of time. Let's just zoom out a tad. Various hardware manufacturers have tried all sorts of gizmos and gadgets. And we can see that. I'll zoom in again. Here's one that I get asked about a lot. That's a corner drawer, made by one company. I'm sure there's a lot of different manufacturers of it, so I'm not going to pick on any one of them. But if you look at the corner drawer design, I think I might have a brochure here somewhere. Have got it? Oh, here we go. One I put here earlier. There's some photos demonstrating how it might look. Okay, so you can see the fronts have to collapse. Actually, I'll put that part there. The fronts have to sort of collapse together to be able to clear either component on the sides, and that then allows the drawer to slide in and out. It's kind of a nifty way of doing it. It's kind of cool, good to look at. But let's just analyse the merits of that for a second. Again, I'll sketch that to probably go through it the best way. As you see, it is kind of groovy, but there are limitations on that sort of a format. Okay, so looking at what you might end up having with one of those drawers, as we just had a look at, you basically require some very fixed geometry on those drawers. There will always have to be a fixed diagonal width of that drawer, so the runners and so forth. Every item has its own thickness, so let's say the back of the drawers, the fronts of the drawers, any overhang you may have, cabinet components, drawer runners, drawer components themselves. So you see there are more and more losses generated by every component that goes in there. Another area of loss is if you are to put items in there. Let's say you were to put something, I'll choose a different colour. Good. Try to put a circular item in there, let's say a plate or a bowl or whatever. It's inefficient for the way you can use the space. Whereas a square area, let's just draw a square. This has got nothing to do with our other drawer, but it does show you similar sized circles. You may get quite a bit more in a given space depending on what it is you're putting in there. So a square is much more effective than these sorts of sharp corners are meant for you to use. Okay. The other thing that's worth noting, which is probably a little bit deceptive the way I've drawn this, really our division is probably, if I do it more correctly, there and there. This area and this area is still lost using this diagonal drawer assembly, which is identical to this area here. So you can see that, let's say this area is that triangle, this area is the same as that triangle. You may as well have written off the corner and then used these two square spaces and just made that a void. So you can see that these diagonal drawers are a bit of a deceptive thing. Maybe not that much of benefit to you, and certainly there's a fair bit of expense involved. I'm sure whoever wants one of these diagonal drawers would have them regardless, but they are a bit of a mixed blessing. There are some other tricks done to use corners. Let me just get rid of some paper. Assemblies like this, where you open the door, a basket comes out with the door as it opens, and another basket follows it out to give you access to a second basket. There are tool units, maybe we can see that, it's probably a little bit vague. That's pretty dodgy. Okay, so the usefulness of that is also a mixed blessing. That's not as clear as you might have. Looking at the losses you may get with that kind of a structure, I'll just zoom back out again. There we go. If you have, an advantage it does have is, of course, it kind of operates behind another space. Like you might have another cabinet here doing whatever it does, unavailable to you. It does allow you to use this space if you've got only access to that space. So you'd have a door opening out and a basket here, a basket there, and they travel out with the door as you open. The first basket comes here, the second basket fills that space. Now, again, the losses are not quite as obvious until you start thinking about it on this kind of design, as may first appear. You can see there's a space here, there's a space there. When this part is in, it doesn't fill the void fully. There is always losses around, operating clearances of each component, pivots and slides. Everything has a loss. Again, if you take out, say, 10% here, 10% there, before long you've lost half the area anyway. So again, it may well have been just as good to write off that corner. These baskets can be very deceptive. The one thing these baskets and the drawers do is, of course, present whatever it is that's on the drawer or in the basket to you. But going back to our drawer design, we could potentially have had this being a square drawer coming out, and that being a square drawer coming out, we'd have to have a bit of a loss so we can clear each other's handles. Might just sketch that, what I'm talking about, so it makes a bit more sense. Okay, so let's say we voided out that corner. So here's our corner cabinet doing its thing. The adjacent cabinets. Let's say we voided out that corner. Again, we have to void out a little bit more, but for the point of exercise, I'll just draw it simply. You have a drawer with its limitations, sliding in and out this way, and at a separate time you could open an opposing drawer. Okay, so with that you have voided this space, but you've used these two spaces very efficiently. They're completely square spaces, which, coming back to what you put in it, they're more efficient for what you can put in the space than perhaps this arrow, I'm going to call it arrow shaped drawer, where there's problems with how you use the space. And in this case you'd have drawers which again would present themselves to you, so the losses are fewer and you still have access to things coming up to you. Another solution which most people would have seen is we have, there's a said corner again, adjacent cabinets doing their thing either side. Is that all in shot? I'll just put that up a tad. And a lazy Susan. Initially they seem like a good idea, but the centre point always has to be an amount in from the edge. Okay, the arc of whatever's on it would be centred on that point, so there's a bit of a, gets larger as it goes back to that line, and here it gets larger as it goes back to that line, but you are restricted. As you can see, there are losses as you go around. There are always voids. You always have to have some kind of lip so that when you're accelerating the lazy Susan components, things don't fly off. There's again operating clearances and so forth. You can see that there are a lot of void spaces. Maybe you can increase these cabinets nearby to try and use up some of that void, but this access area is reduced because we've just, whatever we've introduced as an inset here basically comes off this space here. So as the lazy Susan comes around, it presents to you a small portion, which is not hard to reach, having said that, but it's only presenting a small portion to you. And there are height losses because any item you put on a lazy Susan have to be lifted up over whatever lip or edging you have there. And they can be more problematic for, well, height adjustment and so forth, is a problem. Whereas if we had a corner cabinet with a shelf in it, we can certainly use the same space more fully, although you do have to reach into a shelf rather than having it presented to you. Okay, corner drawers, complex assemblies, Susans. Another thing that we get asked for a lot is corner pantries. The typical sort of, I don't know, square with a corner removed type design, looking at it from above. Again, as I drew in the first example, we have the uprights of the cabinet itself. The door has a thickness. Somehow you have to treat the corners in such a way that's attractive to the user at the end of the day. You've also got a hinge assembly, one side or the other, depending on whether one or two doors. Either way, that width is always being reduced by everything you do, making that space narrower. Sometimes people would like a deeper shelf one way and a shallower shelf the other way. That kind of works rather well. The only thing is, if there's any uprights to carry, say, adjustable shelves in this space, the upright produces a little bit of a dead space there. If it is a kind of an integrated shelf that goes around, which a lot of people like, I kind of like them too, but that's, everyone's got their own choices. I'll just draw that in this purple colour. So you have a shelf with a reasonable access to it, but you still have this problem of this opening. Now what that impacts is, if this is say 600 deep on this side, and that's 600 deep on that side, because you have a bench top running into it, or whatever, the The dimension you really have to have about here is say 500 both ways to make a reasonable opening, all things said and done, to exceed 600 across there, so you can still walk in and out. And bear in mind, you're not going to be carrying much if you've only got 600mm space. If you can make that distance larger, it's better. But 500 plus 600 is 1100. People ask me to make the corner pantries 900, but 900 only leaves 300 here, which would mean an impossible opening which you can't get through. Maybe I'll sketch that reasonably close to scale. Do an opposite side here. Let's say we do 900 by 900. This is why I say always mention that, draw everything with a thickness so you understand what's going on. Now, if we have 600 either side, and we have 900 as the overall from so here to there, that means there's 300 in this space. With any shape where you have a right angle and a 45-degree angle on the side, you have the square root of 2 as the ratio, so 1.41426 blah blah blah. In any case, roughly 1.5 times the 300. So the diagonal here at the front edge would be 450. By the time we've taken off sort of 20mm here, 20mm there, a bit for the hinge, we're definitely under 400 at the effective opening to go through. And there's no way you'd walk through 400mm. Try 400mm. This piece of paper is 300, which is an A4. An A3 is 400 and, 415 long? Something like that. So if you have a piece of A4 paper in front of you, you can start realising how small that space actually is. If you try, say, a passageway door and imagine it only being 400mm wide, you can start understanding the problem we have. So it's always important, flipping this thing back over, it's always important to understand that you are restricting yourself by having a corner pantry. Less than 1100 becomes very problematic. So really you want to go larger. Okay. An alternative kind of pantry design, which has proven to be reasonably popular, is, let's say we have our typical, I don't know, a 600mm depth. Let's just carry that idea through. So 600mm deep and a return of 600mm. I've just defined a line there, it's arbitrary. Again, we're looking for at least 600mm opening. We need a little bit of an inset for that door. So let's say this door was going to be opening that way. We can have a deeper shelf on the end, let's say 400. Again, that's arbitrary, you can pick any dimension you like. Maybe a couple of uprights. For shallow shelves, again, very hard to explain spaces very quickly on a video like this. But if you look at your jars and cans and even things as large as cereal packets, they really don't need that much depth. A lot of items, well, particularly if they're small, you can't stack them one behind the other because they become more and more problematic to use. In that situation, you're better off with drawers if you want to put a whole lot of small items like cans one behind the other. You're best making the shelves deep enough to do the job, but no deeper. They actually give you more effective and more usable space. Also, it's better for rotating stock because you can see what you're using. In a kitchen, rotating stock is quite important. Okay, so we have shallow shelves, let's say 150 to 200 in depth. End shelf of 400. This area here is a space for you to walk in. Being 600 deep, this door is actually out of your way, so you are actually able to stand in this space because the door would be over here when it's opened. So this is actually good access, surprisingly, to that corner. Whereas its equivalent over here, you actually have to physically get within the space to use these shelves. There are merits both ways of any design. This has a better advantage as far as the amount of bench top. Let's say a bench top either side. This is using, let's say, 700 millimeters here and 600 there. It's a total of 1300, so it's costing you 1300 millimeters of bench top in effect. This other design, to be effective, would cost you at least 1100 both ways, so this way and that way of bench space. That costs you 1300 by 600 of bench space. So you can see, you know, it's quite an expensive user of bench space and floor space for that matter to have very, I'm going to say very poor storage. It still brings me back to the same point that corners are a problem and they're worth thinking clearly about. Okay, watch my head. I'm just showing this on a 3D CAD because I can't pick up a kitchen and show you in real life. Now, this area here, just rotate that, you can see that's a breakfast bar arrangement. This area is a breakfast bar. There's notched a little bit around the wall. The walls are actually sort of wireframed in. Don't know how well that shows up, but reasonably. Okay, so you've actually got two corners in this. We have the far corner, this area here. There's an oven. Let's just get this leveled up. Massaged it. Okay. This area here has got one corner problem. Very restricted on this run by a wall, not a wall oven, an underbench type oven arrangement. Well, it's actually an all-in-one, a freestander. We have a refrigerator. The actual space is quite restrictive, so we've done our best to space this out to use the, the wall as well as we could. Okay, so I'm going to blank these two so you can see inside that cabinet. And what we've chosen to do there is have both the doors open away from the corner so as to leave good access. Now, because this run was a little bit narrower, we increased that one to give that diagonal as a wide enough space for your shoulders to get in there and use that void. Okay, we have another window, Now, on this breakfast bar, we were able to use this space. Okay, so there's a small amount of overhang you can see here on the bench top, and part of the cabinet is accessible from the outside. I don't know how clearly that's shown up. Here we go. And also part of it being accessible from inside. Very difficult when you've got everything else in the way. So you can see that that cabinet space is accessible this side, making it shallower, so it's accessible from that side. Perhaps I'll blank out that bench top, make it really easy to see from above. Above, where are we? There. See the space. So you can see the partitioning of the cabinet. This area is left shallower, that area is left shallower, so both sides could be used quite effectively. Actually, we did it for the whole area. So you can see here, this cabinet is quite a large space because we wanted to use the whole depth. We've got the diagonal opening quite large so it can reach through. This diagonal could not be made so large, so I made it shallower for the user to be able to reach in, and using the other side from the outside of the kitchen. And that seemed to work quite well. So there's some solutions for kitchen cabinetry with corners. I guess in summary we have three main points. access to a space, such as your shoulder width, arm reach, and viewing angle. Second point, losses versus gains of any design, mechanism, whatever you may have for using the cabinet. Cabinet might have a certain volume, and the tray, gizmo, shelf, drawer, whatever, has losses in width, depth and height. Also, you might have rails and things to reach over, and which costs you height. The third point to consider is the effectiveness of the space. If you have a triangular shape and you want to put circular objects in it, it may not be very efficient. If it's a circular space, you want to put square objects in it, it may not be very efficient. Or with a small change of dimension, you might be able to get 2 objects of a certain size in, rather than just 1 3/4, which doesn't quite fit. I guess that's it. Thanks for watching. Feel free to subscribe. I hope this has been a benefit to you, and bye for now.